All of the events of the past decade, all of our memories, have something in common. They all took place during the hottest decade ever recorded since humans began keeping temperature records about 150 years ago. In the last decade, the Earth's temperature rose roughly 1/3 of a degree Fahrenheit. Since 1880, it's risen about 1.5 degrees. You might say the Earth's running a fever, and scientists predict it's going to get much worse. Already, we can tally the signs. Global sea level rose by over an inch during the decade, almost twice as fast as the average during the 20th century. Arctic summer sea ice declined by over 300,000 square miles, enough ice to cover the states of Texas and Kentucky. The vast majority of climate scientists say evidence for human-caused warming is clear. But less understood is exactly how this warming will change the complex interactions between our planet's land, water, sky, and the living organisms that inhabit our world. As NASA scientists improve their understanding and predictions about climate change, NASA satellites provide critical data about what's happening on our planet today, real-life observations scientists use to hone their predictions. And NASA gets a global view of 3 major pieces of the climate puzzle: how much of the sun's energy is hitting the Earth, how much of that energy is reflected back out into space, and how much is being trapped, heating the planet. NASA satellites measure the sun's energy, which fluctuates due to a 10 to 12-year cycle. Could increased solar activity be causing global warming? Satellite evidence shows us that the solar cycle has only a slight impact on our planet's temperatures. In fact, even though the last few years have been some of the warmest on record, the sun has been in a deep lull in activity. That means slightly less solar energy has been reaching Earth. And when the solar cycle ramps up again, scientists expect temperatures will rise even a little more. A second piece of the temperature puzzle is our planet's brightness. All other things being equal, a brighter, more reflective planet bounces more energy back to space. Some of the brightest, most reflective areas of our planet are those covered with ice. NASA imagery shows those areas shrinking, especially in the Arctic. As sea ice vanishes into darker ocean, our planet becomes less reflective and warms even further. Clouds also reflect a lot of sunlight. As our planet warms, more water evaporates, potentially creating more clouds. More cloud cover increases the Earth's brightness, possibly helping to cool the planet. But clouds, and the small particles called aerosols that help them form, are climate wildcards. Many current climate models predict some cooling due to increased cloud cover. Will it be enough to significantly slow warming? Scientists are using NASA data to look for the answer. Further complicating the issue is that water vapor is actually the world's most abundant greenhouse gas. That's right, the same molecules that might cool the planet in cloud form actually warm it when they're in the form of a gas. They help create a blanket around the Earth, catching heat radiating from the planet's surface and trapping it within the atmosphere. As the planet warms, more water evaporates from the ocean, creating more of this heat-trapping greenhouse gas. Humans can't directly control the amount of water vapor in the air, but we can have a much greater impact on other major greenhouse gases. Carbon dioxide is the second most prevalent greenhouse gas, and it's our biggest contribution to global warming. Fossil fuel burning releases large amounts of carbon dioxide into the air. NASA satellite instruments capture the infrared signature of carbon dioxide in the global atmosphere. They show a rise throughout the decade. NASA also monitors other greenhouse gases, such as methane, nitrous oxide, and CFCs. In recent years, CFCs have decreased. Methane and nitrous oxide are on the rise. Greenhouse gas is most likely the main contributor to current global warming. It's the key piece of the temperature puzzle, and it's unlocked the door to higher and higher temperatures. In 2010, it marks the end of the hottest decade we've recorded so far. What will the next 10 years hold for the Earth's climate? Computer models predict an even warmer planet, with more extreme weather, less ice, and higher seas. The severity of those changes will depend partly on how our planet's complex system responds, and more importantly, on what choices we make.